Hi lads, how's it going? So today we're going to have a further look at ellipses and parabolas. We're going to look at how to create a tangent to an ellipse, and then we're just going to have a look at one question. All right, so it's not going to be a massive amount. Okay, so it shouldn't take you too long, hopefully. Okay, so the first thing here is it's just a little introduction to ellipses and parabolas, and I think it's a good visual just to make sure that everyone understands it 100%. Okay, so we're going to put a series of cutting planes through a cone here. Okay, so obviously the first cutting plane is going to give us a circle. The second cutting plane is going to give us an ellipse, and the third cutting plane is going to give us a parabola. Okay, so from here, guys, we're just going to have a quick look at drawing an ellipse when you're, I suppose, not given a center axis here. Okay, so we're bisecting the major axis. Okay, and from here we can then draw our ellipse. All right, so I think we know how to do this much. But again, it's no harm to see, just to have a quick revision of it. Okay. Again, this is not too important for us. Okay, I think it's the next slide that we're going to be focusing on. Okay. Okay, lads. This is what I was looking to get to. Okay, so what we need to do, right, is we need to figure out how to create a tangent to an ellipse. All right, so if we think back to a tangent to a circle, a tangent is just a line which is going to cut the outside part of this ellipse in one point only. Okay, but when we think back to the tangent to the circle, there was a construction, there was a method of doing it, and that's no different than the ellipse. All right, so the first thing that we need to do is, at this stage, we should be used to creating our major axis circle, which is the large circle, and the minor axis circle, which goes inside that. Okay. What we need to do is we need to create or find two focal points. Okay, so every ellipse has two focal points, and they're on the major axis line. Okay, so if you just read down here, the focal points are located at a distance of half the major axis from the end of the minor axis. So half the major axis is a distance from here over to the end of the major, so that's half the major. And the minor axis, we know, is the very top point here down to the center. All right, so if we have a look at what that looks like, the distance that we're going is, we're going to set the compass at this distance here. We're going to the very top or the very bottom of our ellipse. We're putting our compass here and we're striking an arc. Where that cuts our major axis in two places, so it'll cut it here at the left and cut it again to the right. That's how you find our two focal points. Okay, so if we just look at this question here, all right, we need to create, does it say it, or do we? Okay, so we need to find the two focal points to begin with. All right, once we've those found, you can start to create your shape. Then, all right, we're not going to do this. Yeah, no, we're not going to bother doing this. It's too simple. Okay, the next question might be a little bit more interesting for us. Have we got a tangent here? No, we don't. Okay, again, we don't. Okay, so this is the one here that I just want to focus in on once again. All right, so for this one, guys, you're given a point P. Okay, what we're looking to do is we're looking to create a tangent which is going to hit off the ellipse at point P. Okay, so the construction method behind this is you take your point P, you connect it back to both focal points. Okay, so focal point 1 and focal point 2. Once you have that done, you bisect this angle inside here. Okay, so you bisect this. Again, if you remember, you do that bisecting your compass at any radius. You strike two arcs that are cutting your lines of the angle that you're looking to bisect, where they cut the line, you set your compass once again and you strike 2 more arcs. Where those arcs intersect, that's your line of intersection. You draw your line through that. Okay, so when we're dealing with the ellipse, this bisector line is known as the normal 2. Okay, so it's the normal 2 line. And basically, we're going to be going at 90 degrees to this line from that point, and that's going to give us our tangent. Okay, so with your sliding set squares, set it up so that your 60-degree side is parallel to your normal 2. Slide it down, and your 30-degree side will then be your tangent. Okay, so you strike that through. You can see that it's a 90-degree angle between the tangent and the normal 2. And look, that's the focus of today's lesson. That's how you get a tangent. All right, so we'll be looking at this in more detail, guys, when we do get back into school. Okay, again, you have got 2 points here. All right, we need to create tangents to those 2 points. First thing you do is you have to find your focal points. So to begin with, you'll get your central axis here. Okay, then with your compass at a distance of half the major axis from your minor axis. Okay, from here or from here, they'll both be the same. You strike 2 points where it cuts your major axis. They're your 2 focal points. Once you have the focal points, the procedure is always the same. Join it back to your point of your tangent, bisect that angle, get your normal 2, and go at 90 degrees to that normal 2. Okay, so that's it in a nutshell, guys. The question that we're going to be looking at is this question here. Okay, so again, if you want to just take a picture of that on your phone, or if you want to just sketch down the measurements for it. Okay, so it's the Eiffel Tower. All right, we have a parabola at the left hand side. The parabola at the right hand side is an exact mirror of that. Okay, and down the bottom we have an ellipse. We're not given the minor axis, but we're given the overall length of the major axis, and we're given the 2 focal points. Okay, so we'd have to figure out what the minor axis is going to be. Okay, so if you're doing this question, the first thing that you probably start with is your parabola. All right, and when we're looking at this parabola here, guys, you just want to identify a few little things. Okay, so the first thing is our vertex is here at B. Okay, so the parabola is kind of sitting on its side. The vertex is B, and if the vertex is B, that means that when we're drawing all our lines back to our corner, it's going to be back to B. Okay, so again, you can set out your rectangle as 180 by 72. Okay, you have to divide it into 5 or 6 parts. Okay, again, do this using your division of lines method with your set square and your compass. Okay, so these guys are divided into 5 parts. Your tracks, okay, so your running lines are always going parallel to the line at the center of the vertex. So parallel to this line here, EB. Once you've this done, you divide the bottom into the same number of parts. Okay, and once you've that done, then guys, it just becomes, I suppose, routine that you should hopefully be getting used to. Okay, so from B, you have somebody going to the first cone, or to pick up a ball at the nearest point to 1, where that cuts the first line, that's the first point on our parabola. Okay, the same for the second one, where he goes to pick up the second ball or to the second cone, where that cuts the track line number 2, that's our second point, and so on for the third, fourth, and 5th point. Okay, and that's how you create your parabola. All right, from that, guys, if you just come back over here, you can see that within this construction here, we have a 10mm gap between the 2 parabolas. All right, so what we're looking to do is we're looking to create this center line down here so that we can just transfer our points straight across. So we step in 5mm and we create that center line down through the middle of our the Eiffel Tower, I think it is. Once we've that done, we can simply bring these lines straight across, and we can then set our compass on the center line, set it to the point in the parabola, and we can just carry that straight across, so it'll be the exact same at the right hand side. We can do that for all our points. Okay, so you can see he's just carrying straight across with his compass. He's setting it at this distance and he's swinging it around. Okay, the same for the remaining 4 points. All right, so once that's created, you can create your mirroring parabola at the right hand side. Okay, you can see it at the top here. All right, we come up 12 and a further 12 to get the very point of our construction of the Eiffel Tower, sorry. And then just the last part of this is our ellipse on the bottom, and it's kind of constructed around what we were talking about earlier. Okay, so the first thing that you're going to do is from the center, you're going to come out half the distance of the major axis to the left and right. Okay, so that's 55 left, 55 right. Okay, and then the focal points are going to be half of 76 to the left and 76 to the right. So that's 34 or 35 plus 3, so 38 millimeters. Okay, so we can draw our major axis circle. We can find our two focal points, but we don't have the measurements for our minor axis. Okay. So the way that we get these guys is that we get the distance from the end of the major axis to the center. Okay, so the focal points are located at a distance of half the major axis from the end of the minor axis. If we think back to that, so half the major axis, we can set that. That's this distance here. We can then come to our focal point with our compass using the same distance. And if we draw an arc here, where that cuts the central axis here, that's going to be our major axis. Okay, so if we just reverse that, if we had our major axis, we'd be doing the exact same method in reverse. If we had our major axis here, we would be setting the compass to half the, or sorry, if we had our minor axis point, we would be setting our compass to half the major axis. We'd be coming back up to our minor point, and we'd be drawing an arc down here. And where that cuts the center line, that will be our focal point. Okay, so we're just doing that in reverse. Okay, so once you have that got, guys, you're on pig's back. You divide up your ellipse using the 60-30 method. Okay, where it cuts the major axis circle, you come straight down, minor axis circle, you come straight out, and you do that for all your points. Okay, and once you've that done, you darken in your question, and once again, just try and keep this neat and tidy with construction lines, and that's the question complete. Okay, so look, guys, that's the only question we're doing this week. Next week, we're going to progress on, and we're going to do 2 junior cert exam questions, which are focused on the ellipse and the parabola. All right, so that comes up every year, comes up as one question, and both topics usually merge into one question. All right, so thanks very much, guys. Have a good week, and I'll chat to you next week.